Okay. First of all, this first question has a couple things that we're going to highlight. It says to find surface area and volume of a cube with a side length of 4 centimeters. Uh-oh. There it is. Smartboard is delayed again. So, surface area and volume. Surface area is all the area that it would take, I sometimes imagine, to paint the whole thing. You know that a cube has all the sides exactly the same, like this, and this one has all sides that are 4 centimeters. If you could open it up, how many squares would there be on a cube?
8.
See if you can count them. 1 on the top, 1 on the bottom,
6.
and then 4 along the other side. So for the surface area, we can think about 6 squares. 1 on the top, 1 on the bottom, then 1, 2, 3, 4 around the outside. And what is the area of one of those squares? So now is a question, do you remember a formula for finding the area of a square or area of a rectangle?
Maybe 2.
How do I find the area? Length times width. Adding would be the perimeter, multiplying them. So we get an area of one of the squares is 16. So the surface area in total will be 6 squares, each of them times 16, and you'd be able to do this on your calculator and get 96. And the units for area are centimeters squared. Our volume formula, and on the test I'll give you the formulas. Our volume formula is length times width times height. And since the length is 4, and the width is 4, and the height is 4, this makes 4 cubed. Which is kind of interesting because we call it a cube. And it has the exponent of a 3, which is cubed. And if you multiply this out, and our units for volume are centimeters cubed. Your next question in your notes didn't work out very well. It's supposed to look like this. But what's missing in your notes?
The circle.
The circle cut out.
So you just draw a circle?
Or you could redraw this right beside it. Maybe draw as best as you can a square. Then draw a circle touching the edges as best as you can. Ooh, that's not bad. It's a little fat on the bottom. That's okay. And then color in the corners. Ooh, I feel like I should go to coloring school. Okay. Yeah, the one I made on the computer is a little bit nicer, but that's okay. So a circle is inscribed, which means it's drawn inside of a square with a side length of 20 centimeters. And we need to find the area that is shaded. So first of all, can we come up with the idea? Before we get formulas, before we go into numbers, if you were able to get any formulas you wanted, and you wanted to find the area of that shaded part, what would you do?
Figure out the volume.
Okay. Well, we're not, volume is when we got 3 dimensions, we're only dealing with 2 dimensions, but figure out the area We have to do something with areas to get the area of the shaded part on the outside.
Is it added or multiplication?
I'm not worried about, you don't have to say what the formulas are, just the idea. Like if you, any number you wanted, you'd say, Mr. J, I'd like to know what the area of the square is. I'd be like, area of the square is 400 centimeters squared. You'd be like, okay, is that helpful?
No.
How could I find the area of just this part?
Entonces, en cada lado de pieza, como son 4, en cada una da 5 y por eso es 20 metros.
Okay. Could try to figure out each one separately, but how would you do that?
Divide
Dividing what?
the 20,
Dividing the 20 by,
maybe 4.
okay, that would cut it perfectly into quarters. You divide the 20 into 4. They're not quite triangles because it's rounded. What's the picture that you have on yours that didn't work out?
This blank square.
The whole square. Could you figure out what that area is? The whole thing, shaded in. And if you had a formula, could you find the area of the whole circle?
Yeah.
So we have formulas for both of those. We have formulas for the square and we have formulas for the circle. If you had formulas for both of those, any ideas how you could get this part around the outside?
Add them together.
Well, if I add them together, I think if I put the two
No.
together and shade it, it would be way more shaded than that. You're close to it though.
Can you like put the mix the formulas together?
I'm just going to spend some time coloring because obviously I'm really good at it. There we go. Okay, so the area of the square is length times width, or side squared. So the area is equal to s squared. And the area of a triangle, here's the formula for an area of a triangle. You've probably seen that one before. Pi times the radius squared. So both formulas have exponents in them. If I told you this was 400, and I go to my calculator here, because if this is 20 from here to here, which is the same as the radius, would be 10. A little bit like that. You, of course, would use your calculator.
How would you put that into your calculator?
Oh, in your calculator, there would be a button. You should find where your calculator has the pi button. So, on my calculator, it's up here. I have to go second and then there to get it. And then the radius was 10 squared. How close was I? Oh, I was off by 1 decimal place. I had 1.5. And then rounded would be 1.6.
Wait, so you have to go second and then what?
Second, and then you see where the pi button is above this one? You push second in that button. Okay. So if this one is 400 and this one is 314-ish, how do I know that this shaded part here is about 86? How do I know that? What did I do? How did I use those other numbers to help me figure it out?
Do you like subtract or divide?
Does it make sense that if you took the whole area of the circle and then subtracted the circle, then you would be left with just the unshaded part in between, right? Because I could take this circle, put it back in, it fills it up. Ooh, That matches pretty nicely. I'm pretty impressed with myself. And then I subtract the circle out, then I would be left with just the parts in total. So we had to do a little problem solving here. The shaded area is going to equal the area, area of the square, put that in brackets, minus the area of the circle. So I had 400 was the area of my square, minus 314.159, dot, dot, dot. And that got me about 86, I guess it's 85.84. No, 84.84. I would use a calculator though. 85.84. It was better.
Should we write that all down?
85.84.
Should we write that all down?
Yes. Does that strategy make sense to you, what we did?
Yeah.
How we took, to find that shaded part, we thought about the circle and the square separately, and then said if I subtract out the circle, then I would be left with just the parts around the outside. Let me know when you're done. Next question. Find the area of that blue square that is attached to the hypotenuse of the triangle. So we've got some problem solving here. There's something from grade 8 that you did with triangles that were right angled that let you find the hypotenuse.
We did.
Do you remember that formula?
Nope.
Do you remember the formula with a triangle that's a right angle where you fuck with all three sides? Does that look familiar now that you see it again?
No.
No? If not, this has a special name. It is a special...
I knew it! Sorry.
It's called the Pythagorean theorem. It's true for any triangle that has a 90 degree, that one side plus the other side equals, does anybody know what the long side is called of a right angle triangle? Do you need a hint?
Yes.
Starts with an H, rhymes with hypotenuse. Any guesses? Oh, you guys are amazing. Hypotenuse. And that is always the C in the formula. So if I want to find out how long that side is, I would have to do one side squared plus the other side squared equals C squared. Order of operations now become important. Do we add first or do we do exponents first?
Exponents.
Exponents first. So 5 times 5, that's 25.
22.
Oh, there's a few of you that remember 12 times 12.
144.
144. Add them together, you get 169.
I don't got that.
Do we remember what is the opposite of squaring?
Did we learn this?
Yes, we did. Opposite of squaring is square rooting. And unless somebody knows this in their head, what times what is 169? Then you'd have to go to your
9
calculator.
times, wait, no.
9 times 9 is 81.
13.
14 times 14 is 196.
6.
6 times 6 is 36.
13?
13 times 13 is 169. You got it.
I said that.
So then this side is 13, and then the area of a square is length times width. 13 times 13, the area of that square will be 169. There's no units in this one, so I can just circle that as my final answer. This formula you are going to use a lot this year, next year, all the way to grade 12 in math. A squared plus b squared equals c squared. Yes.
A is number 5, right?
Yeah. And it doesn't matter if you make the a5 or the b5. A and the b are just the two sides that are not the hypotenuse. But it's always important that the hypotenuse side is by itself. And it's actually, this is quite rare that all three numbers work out so nicely. Usually when you make out triangles and you go to your calculator, one of them is a decimal. So this is actually a famous triangle. Not as famous as this one. This is probably the most famous right angle triangle.
What do you mean by famous? Like,
Well known,
like most used?
right? Like, if I'm walking down the street and nobody goes, "Oh, there's Mr. Jarrett. So famous, can I get an autograph?" Right? That's a famous triangle.
Una pregunta. ¿Cómo podemos saber la cantidad de la S?
¿De esto?
De la S.
Or did I say? Okay.
13.
Almost say
I'm still confused.
aquí.
I have a question.
Tres.
I have a question about that, right? The C with the up to the power of 2, whatever, right?
Yeah.
Why do you get rid of the 2?
Because this means something times something is 169. If I want to find out what it is, I have to do the square root because that's the opposite of square. Okay. Yeah, 3, 4, 5 is probably most popular. Carpenters use the 3, 4, 5 when they get to a corner. If they want to make it 90 degrees, and they're like, "I hope this is 90 degrees." They will measure maybe 3 feet here on one side and make a mark, and then they'll measure 4 feet here. And if this side, when they measure from those 2 points, is 5, then they know their wall is perfect 90 degrees. If it's not 5, then it's either too little or too wide, and then they have to make some adjustments. And if you don't make your walls at 90 degrees, all of a sudden your house starts to get a little bit funny. So it's pretty important for carpenters to make 90 degrees, and they can use the 3, 4, 5 triangle to do that. I'm going to make that a little bit bigger so you can see it better. Our next application of exponents is in biology. Scientists who study bacteria use exponents. The growth of bacteria is caused by a process which causes the division of cells. And every time it divides, you get double. So what we have here is an example. Okay, you start off with 500 bacteria at 8 o'clock. And it's going to divide every hour. So does it make sense that if you have 500 at 8 o'clock, at 9 o'clock you would have 1,000? because they divide again.
¿Me puede dar más el ticket, por favor?
¿Cómo?
Si me puede dar más el ticket.
¿Ticket de qué?
El ticket. De lo de esto, por favor.
¿Otro?
Si puede.
¿Otro más? Sí, pero tengo que...
Ah, ok.
La otra profesora ya tiene. So then the next hour, if you had 1,000 doubled again, then you'd have 2,000. And doubled again, and doubled again. And we can show these with exponents, because this last one we could say this is 500 times by 2, and I've 1, 2, 3, 4, 1, 2, 3, 4 of them, times 2 to the 4th. Now after 24 hours, we could write this, although that'd be a little bit annoying. Wouldn't it be nicer to write this as 500 times by 2? How many 2's would be there after 24 hours? After 1 hour, there's 1 2. After 2 hours, there's 2 2's. After 3 hours, 3 2's. After 24 hours, it would have doubled 24 times. And so we can write a formula here that your population in this case is 500 times by 2 where n is the number of hours. So using an exponent here is super helpful. So now we're going to solve some questions with powers.
Wait, most of you.
Okay, no problem.
We have same question now as in group.
Same questions? That's good.
I'm good now.
You good? So,
No.
oh. Okay.
Are you with a worksheet on this?
Yes.
Is it due at the end of class?
I think I'll give you today and tomorrow because we're going to be, I think, short a little bit of time.
Is it? Can we use it to study for the test?
Yeah. So, oh my goodness, this is like the worst example. Mosquitoes, and they're doubling every week. You have 100 mosquitoes at the beginning. How many would there be after 4 weeks?
400.
Doubling every week. So you're starting off with 100.
600.
And then after 1 week, it would double. How many would there be?
200.
200. After 2 weeks, how many would there be?
400.
400. After 3 weeks?
So it would be 800.
And after 4 weeks?
1600.
Now, it's doubled once, twice, 3, 4 times. This is the same as 100 doubled 4 times. How many weeks are there in 3 months?
12.
12 weeks. Or no, it's actually 13. One will have, because some months have 3. Every 3rd month you have a 3rd week. 13 weeks. So I would take my idea as a formula. Maybe this is why we have winters in Winnipeg, so that the mosquitoes can't keep doubling. It's almost been too nice out, don't you think? It's supposed to get cold though.
It's supposed to be like -7.
That's not too bad though.
No, but it's not supposed to snow.
Type this into your calculator.
Would it be just 1300 or no?
Type this into your calculator, and did you get 819,200 mosquitoes? That is a lot of mosquitoes. How many weeks would it take to get to 12,800 mosquitoes? One thing we could do is we could just keep doubling. 5, you're at 3,200. 4, you're at 6,400. I mean, 6,
Is there
you're
an
at
easier way?
6,400.
Instead of doubling it, is there an easier way? Like,
So,
simpler.
or you could say, this is my formula, and it has to equal this. And with the formula, I could divide both sides by 100, and then I would get this. It's not going to take you too long to try a number before you get an answer that works. Someone give me a guess for n.
40.
40? We'll see how close you are. This is what, if you pick 40,
Oh my goodness.
that's what you get. I think it's too big. We only want to get 128, and you got that number. So I'm guessing it's less than 40. Anybody else want to guess a number? 'Cause this was 40, way too big.
20?
20. 20 is over 1,000,000. We want to get 128.
I don't know, 7.
7. Ooh, you got it. That was crazy. There it is. N is 7. Which, if you would have kept doubling, look at 5 would be 3,200, 6 would be 6,400, 7 is 120, is 12,800. So both methods would work for figuring this out. And with that, we turn. We're on our last page of our notes.
Is there a way to write that into your calculator?
There isn't. What we would do is you would do 2, and then you do this little hat button on your calculator, and then you put in different numbers until it worked. To solve it with an algebraic way, you'd have to know logarithms in grade 12, which that's a ways away. A patch of algae found on the surface of a pond doubles in size every month. This is a logic question. You're not going to have to do any mathematics on your paper here, but you should be able to answer this. After 6 months, the algae covered the entire pond. How long did it take
3.
to cover half of it?
3 months.
I like what you're doing there. You took 6 and divided it by 2 because you wanted half and said 3, but no. The answer is not 3.
Is it lower?
You got, first of all, think about what the question is saying.
double.
It doubles every month. And it filled it up completely at 6 months.
2 months.
How long would it take to cover half of it?
2.5.
Not 2.5 months.
Is it 2?
Not 2 months.
Is it a decimal?
It's not even a decimal. It's a nice number.
1.
1, 4, no.
1.
5. Are we just guessing?
Yeah.
Because there's like, it's going to be a nice number, so I have 5 guesses. I'm going
4.
to guess it right. 1, 2, 3, 4, 5. Did I get it right? Yes. It's one of those numbers.
4.
5.
Why is it the number that you want it? So you, next one is you tell me a number, and then you tell me why you think that number is right. You want to go to the wash?
Is it 4?
Is it 4? Why do you think it's 4? Why should it be 4?
I don't
You don't know. Okay, then that's a guess. We have to come up with an idea.
2.
2, and why do you think it should be 2?
Because when it doubles, it's like 2 times 3 equals 4.
It doubles every month. So if it's 2 and it's half covered, then the next month it would be completely covered if it doubled.
So 1 month.
So the answer is
5.
5 months to cover half. Because if it doubles, if it was half covered, it doubles every month. Right? Here's the pond. Beautiful pond. Half covered with algae. If it is half covered and you double it, the next month it would be all covered.
Wait, I'm so confused.
Does that make sense?
But the thing is that it takes 6 months, right? So
It's 6 months to cover the whole thing, so if I work my way backwards, if it doubles every month, if I work my way backwards, if I go back 1 month, I would have to take half away.
but 5. When you double 5, it's 10.
You double 5, it's 10, but it's not saying that you double the months. It's saying the algae doubles every month. So if it was half full at 5, and you doubled it, it'd be all full at 6.
The paper you give us, are we able to just take it home and work on it?
You can take it home and work on it. I just got to update attendance here. Population of 100 frogs tripled each year.
2.
How many frogs would there be in 5 years?
Yes, but 2,000. Wait, no, 24,300.
Okay, let's see.
I don't know if I did it right. I think I did it wrong.
You're a little bit wrong. Let's start making, if you're stuck on these ones, you can make a chart. So year 0, you have 100 frogs. At the end of year 1, if it triples, how many would you have?
300.
300. At the end of year 2, if it tripled, you would have?
600.
No, it's not
Wait, no,
tripling.
900.
900, times it by 3. End of year 3, 2,700. End of year 4, oh my goodness, 8,100. End of year 5,
Wait, 4 is not. Wait.
24,300.
Wait, you tripled it, right? So you times it by 3 each time?
Times it by 3 each time. $24,500. The shortcut would be to do this. You started with 100. It tripled how many times? 5 times. And you get 24,300.
Oh, that's what I got. I just said it wrong.
10 years. You see, the formula is really nice.
Would just be 3.
We put it in 10 years. Oh my goodness, this is like a frog disaster. 5,904,900. There's that many frogs, I think everybody would have to start liking frog legs. 50 years. How big of a number do you think this is going to be?
$1 billion.
Let's try it. Get out your calculators. It's so big that my calculator goes to scientific notation.
It says E at the end.
It has an E at the end. I'll show you what that means. So I'm going to write the decimals. I'm going to round to 3 decimals, and that E at the end means scientific notation times 10 to the 25, which means that this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's about how big the number is supposed to be. That is too many frogs. So that's scientific notation. Why is it nice? Because it was super annoying to write all those zeros. So when we have really big numbers, sometimes we also use exponents for scientific notation. All right, I'm going to skip those last 2 questions. You can come see me if you want to know how to do them. They won't be on your test. And I'm going to stop our video here.